So CH3CH2 NH2 reacting with acetic anhydride, that is CH3CO twice O, and this gives two product. You have to write down the product. You can use the mechanism. So amide is less reactive and anhydride. So this is anhydride. We have discussed anhydride is less reactive. More reactive. Anhydride is amide is more reactive. So this is more reactive. And anhydride, that is less reactive. So if you see the reactivity series, amide comes lower and anhydride come upper. So lower one displaces the upper one. That's the same reaction. We've already discussed in the classes. So you see, in this case you will have CH3, CH2, NH2. Now this will act as a nucleophile, and this side you have CH3, C double bond O. So let me write C double bond O, CH3, CH3. Now this will attack here, this opens, and in the next step it will return, and then this goes. Are you getting or not? So if I follow the two steps in one step, I can write, and I have to lose H plus from here also. So I will have CH3, CH2, and H, C double bond O, CH3. Now H plus that is coming from here, I can add here, so I will get CH3, C double bond OOH. So these are the two possible products we will have. So you will have one acid plus one amide. So you have acid, and another you can say this is amide. The upper one is acid and the lower one is amide. Are you getting? So you see what is happening in this case. Initially you have an amine, and you have an anhydride, and then this will give you acid plus acid amide. Are you getting or not? Simple one. So only thing is you have to realize the fact that amine is more reactive. This is amine, not amide. Sometimes I have said amide. So this is amine. Amine is more reactive than anhydride. So this will act as a nucleophile. Nitrogen will act as a nucleophile. It will attack. And there is a leaving group that is if this leaving group goes, you will have an acid. So this is the final product. You will have acid plus acid amide. You can simply say acid anhydride. So final product is amide plus acid, not acid amide, simply say amide. Now let us discuss this problem. So you have to convert this compound nitrobenzene to orthophenol nitrobenzene, or you can say meta-nitrophenol. So this is treated as a derivative of phenol, so this is meta-nitrophenol. So you can say this is nothing but meta-nitrophenol. So let us write how will you do this one. So you have to add one OH group. So you can follow diazonium synthesis. You can have N2 plus, and if N2 plus reacts with H2O in hot water, H2O can attack and finally we'll have OH. So you can use that fact. Okay, so let us discuss what we will do is, first if I treat with HNO2H2SO4. So I can do nitration. So in the first step, that is a nitration step, simple. So I will have a meta directing group attached. So you will have two nitro groups. One is here and another is at meta position. Are you getting? And now if you treat with Na2S, and this only reduces one of the NO2 groups. So this reagent is a mild reducing agent. So this will reduce one of the NO2 groups. So you will have something like this. So this will be NO2 and there will be NH2. And now things are simple. If you treat with NaNO2HCl, you will have diazonium cation. So next is NaNa2HCl. You will have the diazonium cation form. So here you have NO2 and here you have N2 plus. Are you getting or not? And if you HCl, then N2 plus Cl minus. And now this is treated with H2O, simply H2O, and this is done. Heating is also present in the solution mixture, some high temperature. So you will have N2Cl will be converted to OH. So the final product will be this, OH. Are you getting? So this is a quite simple problem. You have to only remember one fact: if benzene contains two NO2 group, if I want to reduce only one NO2 group, then I have to use Na2S, that is sodium sulfide, or sometimes you can also use NH4 whole twice. So there are two reagents. So either you can use Na2S or NH4 twice S, because NH4 plus S2 minus, so I have to take 2 ammonia. Let us discuss the next problem.